All right, go ahead and check your answers from the interior part, the 1 through 4. See how you did. If you have a question, find a neighbor to ask or make a mark so you know to ask me about it when we get back. Moving on to exterior angles. Here are some triangles, and based on just some things that we already know, if this is an equilateral triangle, then that means these would all be 60. And we also know that this is a linear pair, so together they have to equal 180. So all of these would be 120. And then if we add those up, those three together equal 360. So these angles together is 360. On our next triangle, we have a little bit of work to do. If this one's 60, then 3 would have to be 120. If this is 70, 180 minus 70 is 110. Oops, should write that. And then to find out what this angle is, we would need to do some interior angle math. We know there's 180 degrees total. So if we subtract the 70 and the 60 from 180, this one is 50. So then 180 minus 50, this outside one is 130. Now again, if we add those up, 130 and 120 and 110, we get 360 again. So these equal 360. Let's look at some quadrilaterals. If this is a square, then we know that all of these are right angles inside, which would mean that all of those are right angles outside in order to keep our linear pair situation true. So all of these equal 90 each, and then all together we get 360. Are you seeing a pattern yet? There should be a pattern. Doing our math here, subtracting the interior from 180 because we're making a linear pair to find that exterior angle. Angle 1 would have to be 70. Angle 2 would have to be 85. Angle 3 would be 110. And then angle 4, see, here is where this pattern might help us out. Because we know that the interior has to be 360. So we could take the time to do 360 minus 110 minus 95 minus 70. So I know that this is 85 inside. And then do the 180 minus 85 to know that this is 95. That's one way to solve this kind of problem. But if you've noticed that my interior angles are all equaling 360 anyway, I'm sorry, my exterior angles are all equaling 360 anyway, I could do 360 minus the ones I already know. 360 minus 110 minus 85 minus 70, and I get 95. Imagine that. Some pentagons. Spoiler alert, the exterior is 360. Okay. Sorry to burst your bubble. So the sum of any convex polygon, the exterior angles, is going to equal 360. So it doesn't matter what it is. It's going to be 360, okay? So if I have a regular octagon, find the measure of an interior angle and an exterior angle of a regular octagon. So interior angles, I would have n minus 2, which equals 6, times 180, Remember, we already did this on the front, but just so you have the steps. So there's 1080 total, and I have 8 angles. So each one is 135. So if it's 135 inside, and I make that linear pair, 180 minus 135 would be 45 outside. Also remember, there's 360 outside, and I have 8 angles that it has to be a part of. Oh, go away. 360 divided by 8 equals 45. So we're back to this multiple ways of solving the same problem. Or if the measure of an exterior angle to regular polygon is 30, find the measure of the interior angle and the number of sides. So if I have 360 degrees total divided by the 30 degrees that it is, then it would be 12 sides. And if my angle inside is 30, then my angle outside would have to be 180 minus 30, which is 150. So the interior angle would be 150. It has 12 sides. You could also solve it with, if you know how many sides it is, n minus 2 times 180 divided by 12, you get the same thing. So to find the measure of each exterior angle of regular polygon, take 360 divided by n. So it's the total degrees outside divided by how many angles there are. So now you have some time to do practice problems 1. It starts on the front. The practice problem 1, 2, 3, and 4. So pause it, do those problems, come back and check your answers. So here are those answers for 1 through 4. And then you have some class time to work on 1 through 15, like the rest of that page, as practice. And bring that back to class Friday.